Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus questions from the chapter on recursively defined sequences and Newton's method. So question 5 is asking us to use Newton's method to approximate the cube root of 7. So recall that Newton's method uses this recursively defined sequence and it's approximating a solution to f of x equals 0. So the idea is f of x equals 0 is this x-intercept here. If we have an initial guess, then we can use this formula here. This formula here is telling us where the tangent at that initial guess meets the x-axis again, and that's closer to this root that we're trying to approximate. If I do it again, I get even closer to the root that I'm approximating. And so this is going to converge towards the solution to f of x equals 0. So if I want to approximate the cube root of 7, I'm going to need a function that the cube root of 7 is a 0 for. So let's start off by defining that function. Let f of x equal, well, the cube root of 7 is a solution to x cubed minus 7 equals 0. It's a root of this polynomial here. And so we'll let f of x equal that, and then the cube root of 7 is y0, where it intersects the x-axis there. And we'll need an initial guess, so let's have an initial guess of, well, the cube root of 7 is almost the cube root of 8, it's just slightly smaller. The cube root of 8 I know is 2. So let's say our initial guess is going to be 2, which is pretty close to the cube root of 7. Now to apply this recursion here, I need f of xn and I need an f dash. So if f of x is x cubed minus 7, then f dash of x cubed differentiates to 3x squared, 7 differentiates to 0. So let's write down our sequence then. So x naught is our initial guess 2, and I might just write the formula over here a bit more explicitly. Xn plus 1 is xn, so the term before, minus f of xn divided by f dash of xn. Well, f of xn is xn cubed minus 7, and f dash of xn is 3 times xn squared there on the denominator. So this is the recursive formula that's going to converge to the cube root of 7 there. So if our initial guess is 0, our initial guess is 2, then let's just manually calculate our our next term in the sequence. So x1 is going to be x0 minus x0 cubed minus 7 all over 3 times x0 squared. So that's just going to be 2 minus 2 cubed minus 7 over 3 times 2 squared. So that's 2 minus 1 over 12, so 2 minus a 12th, which is 1 and 11 twelfths. Let's write that to so many decimal places. So that's 1.91. Oh, we want it to 5 decimal places. So 1.91667. I'll round it to 5 decimal places there. Okay, so that's our next term in the sequence, which is slightly closer to the cube root of 7 than 2 is. Now, this is a bit painful if I'm going to manually enter all these in, so I'm going to use the same trick I used before. We'll enter 2 in our calculator. That's in the memory of our calculator, so we'll clear it and we'll enter this formula in, but for xn I'm going to type the A and S button, the answer button, which recalls the previous term. So I want the answer minus the answer cubed minus 7 all over 3 times the answer squared. So if I press equals then, that should give me this 1 and 11 twelfths, which is 1.91667 to 5 decimal places. If I press equals again, I'm going to get the next term in the sequence. So that's going to give me 1.9129. Now it's 3/8, so I'm going to round that to 4. correct to 5 decimal places. If I press equals again, I'll get the next term in the sequence is 1.91293 to 5 decimal places. At this stage, I still don't know what the cube root of 7 is, correct to 5 decimal places. I don't know whether it's 94 or 93 at the end there. But if I press equals again, I will see that the next term is 1.91293 still to 5 decimal places. And if I keep pressing equals, in fact, the first 9 decimal places don't even change. So it's definitely this correct to 5 decimal places. So even if I did another couple, you'll see that it's exactly the same. Okay, so hence, using Newton's method, the cube root of 7 is approximately 1.91293 correct to 5 decimal places there. And if you just press the cube root of 7, you will see, yes, that's exactly what our calculator thinks as well. Now just to refer to this picture again, the cube root of the x cubed minus 7, that's a cubic shifted down 7. So that's a cubic here as if it was shifted down 7. So here is the cube root of 7 that we're trying to approximate, the 0. And we were starting with an initial guess of 2. And when you draw the tangent at 2 and find where that intersects the x-axis, that point there is the 1 and 11/12 there, the 1 and 11/12. So that's slightly closer to the cube root of 7 there, right? And it's this formula that's giving us that next term in the sequence. If I put that and put that into the formula, I'll get x2, and that was giving us the 1.91294 as the next closest thing towards the cube root of 7, right? So what this sequence is doing is it's finding where the tangents intersect the x-axis, and it's getting closer and closer to this 0 there. Okay, so that's using Newton's method to approximate the cube root of 7.